This is the notes for day 2 on surface area. And just to introduce you to some of the format, the left column here is a space that is designed for you guys to write questions for either yourself or for the teacher. So please make sure anything that you need to ask, and obviously I am not there to answer your questions, jot it down on the left. There should be 2 extra pieces of information nearby. One is your SOL formula sheet, and the second is a calculator. Make sure both are nearby. To get started, I think what will be easiest is actually to start with example 2, because I think this is probably what you're more familiar with. So we're going to find the surface area of the right prism over here. Now, to do so, I think what's helpful is to first identify what is the name of this prism. Hopefully you're able to distinguish that this is a rectangular prism. Now, this figure is probably one of the more familiar figures, and if you look at your formula sheet, there's going to be a formula that's associated with it that you probably are familiar with as well. So if you look, hopefully you kind of recognize that this is the shape that we're going to be using, and if you look at the question, it is asking for surface area. So the surface area formula is going to be 2LW plus 2LH plus 2WH. So to show all of my work, I'm going to write down that formula. Now, if I look at the picture on the right, you want to pay attention to what all these numbers are telling you. The 16 is referring to the length, the 4 is the width, and the 9 is the height. Now, if you decided to call things differently, and maybe you called this the width and that's the length, don't worry about it, you should still get the same answer. So moving along, I'm going to substitute these values here in for the formula. Oopsies, that should be a 9. Don't make that mistake. Okay, now whenever you do substitution, especially with these number of numbers, I think it's always a good idea just to double check to make sure that you didn't copy a number too many extra times, well, extra at all. We're look good. All right, so now we're going to get out the calculator and start these calculations. Now, if you did all of this and typed it in as is in your calculator, that's fine. I'm going to do it separately just because that's how I'm going to do it. So far we have 128 plus 288, and then the last value is going to be 72. I'm now going to add those 3 numbers, and that's going to be the surface area for the right prism. Oopsies, I typed that in wrong. Always a good idea to make sure you're paying attention. So we have 488 for the surface area. Now your units are going to be centimeters squared. So any units that have an area associated with it is going to be a centimeter squared or inches squared or feet squared type of answer. Now that problem you probably could have done on your own. Hopefully you can. Now at least. So now let's continue with example number 3. A can of soup has a height of 4.5 inches and a radius of 3 inches. What is the approximate area of the label that covers the can of soup? So if we're talking about a can of soup, what type of solid are we talking about? Hopefully you're recognizing that we are talking about a cylinder. So I'm going to draw a sketch and label it based upon these 2 values. So to draw a cylinder, I kind of draw something that looks actually a little more oval-like. Then I draw 2 lines straight down, and then I draw a curve here on the bottom and another dash curve going the other way. And that allows me to tell a little bit more easily that I'm talking about this is the top, this is the bottom, and this is something I can't see but I know that it is back there. Now labeling this, height is referring to the distance between the 2 circles. So this is going to be a 4.5 inches. It says that it has a radius of 3 inches. So I'm going to put a dot in the middle there. And I don't think this is going to, well, I'll squeeze it in. Call it a 3 there. Now, when we're talking about a label that covers a can of soup, that doesn't actually mean the entire surface area. If you think about it, on a can of soup, the top and the bottom of the can don't have any label. It's not covered at all. The label just wraps around the can. So we're not actually looking for surface area, we're looking for something else. If you look at your formula sheet, you have, for a cylinder, a volume formula, an LA formula, and an SA formula. LA stands for lateral area. So if you ever forget what some of these letters stand for on your formula sheet, on the bottom of the page you have these abbreviations in place. So LA, lateral area. And lateral area means everything but not the basis. But no basis. So I'm going to write down the formula for the lateral area of a cylinder. And if we go back to our formula sheet and copy it down, it's going to be 2 pi RH. Maybe I should say this has 2 pi R H. And hopefully you just remember what 2 pi R is a formula for. Now the radius is 3 and the height is 4.5. So I'm going to type this in, so 2 times 3 times 4.5. And you might notice that I didn't actually type in the pi button. I did that on purpose because I figured this is a great opportunity to mention something. There are two ways of writing your answer here. One is saying 27 pi, and the second one says that I'm going to actually type in my calculator 27 times pi and get this a number here, 84.82. The question, if we look at this, it's asking for an approximate area, and I wrote this down wrong, 84.82. So again, back to the question, it's asking for an approximate answer. So I want you guys to notice is that this 27 pi here, this is an exact answer. There's no rounding involved. This right here is an approximate answer because we had a round in order to get the number. Now if you think about it, pi keeps on going with that end. So we always use an approximate number if we multiply by 3.14 or if we use actually a few more decimal places. So this is the answer that we want for this problem because it's asking for the approximate area. Now hopefully you recognize I did forget one thing, and that is inches squared. So I'm going to squeeze that in here, inches squared. Okay? Now I'm going to stop the video here and I'm going to have a separate video for example number 1. So please watch the video on example 1 after completing this, and also remember to jot down any questions you have on the space on the left for me or for yourself.